Good morning. You're welcome to our lecture today on pharmaceutical calculation, ability 253. We are entering another topic today, enumeration and notations. Actually, when we treated numbers and numerals, I used the opportunity to talk about what? Enumeration. As you can see, numbers and what? Numerals. Enumeration. What do you think here? Come in. It came from where? Am I communicating? So that's why when I was teaching numerals, I was teaching them side by side. So that you will appreciate what we're talking about. All these topics are linked. One. If you have mixed a step, you find it difficult trying to understand another step. We're moving now. I'm not going to. We're going to waste our time here again in enumeration again. Am I communicating? I'm going straight to what? Notation. Now, if you don't understand numbers, you cannot understand numerals. Neither will you be able to understand what? Enumeration. It goes like that. So please, that's why I try as much as possible. I do all in my capacity to ensure that you follow up immediately. Immediately. You don't wait till whenever your mid-semester exam comes, you start opening your book, you won't understand anything. You start having issues up and down. That's why every day, what I do is try to look for a way to make sure that you people follow, you understand what we are doing. So now we are going to what? Notations. I said I introduced notation in our last class. I told you that notation is nothing but the different forms numbers can do what? Appear. Am I communicating? Different what? Forms numbers can do what? Appear. Numbers can just appear at the one you are seeing, the non-ordinary form you know it to be. Am I communicating? Like 1, 2, 3, 500. Ordinary forms you know it to do what? D. Let me bring that a particular number now. So you appreciate what we're talking about. Look at this number. 2,000. 2,000 is a number you know, right? In your mind, you conceive it as 2,000, right? Either is from a measured quantity or from a counted what? Quantity. Am I communicating? If you denominate it, let's say 2,000 centimeter, for example. Now you have given it a unit. It's now a denominate what? Number. I think I mentioned this in this class before. A number can be a denominate number or abstract. As it is now, it's still what? Abstract. But once you put something, either you put Newton, or you put cm, or you put milligram, or you put kilogram, these things are different denominations. You have made it a what? A denominate number. Am I communicating? Now, we are just working with abstract number now. I want to use to talk about what we mean by different forms a number can do what? Appear. This is just ordinary form. The one you know. 2,000 to do what? To be. Come in. The one you know 2,000 to what? To be. Now, let's assume you have if we have something like this, even though we are not familiar with it, but is it a fraction?
Yes.
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 Even though this one may not be what? Significant, but it's still a what?
Fraction.
That's why you can call 2,000 a rational number. Are we together? Now. Look at this thing, 2,000.0. Is it also a fraction? Is this one not a fraction? Even though we are not discussing, but I'll still get there. Is a type of fraction called what? Decimal what? Fraction. Under fraction we have common and what? Decimal. Am I communicating? It's also a fraction. Now look at this. Hello, no noise please. Look at this. Look at this. 2 times 3 is 4. 3. Look at this. 2 times 3 is 4. 3. What's this? What form is this?
Standard.
Ordinary form, common fraction, decimal fraction, standard form, or exponential notation, or scientific notation. You can call it standard form, exponential notation, or scientific what? Notation. You can call it standard form. This is what? Ordinary. Ordinary form. 2000, just ordinary form. This is what? Common what? Common fraction. This is what? Decimal what? Fraction. This is what? Standard form, or you call it, or scientific what? Notation, or what? Exponential notation. Are we together? Now, if you have 3 raised to the power 3, this is also this is a what? Another form we call what? Index what? Form. Index what? Form. This is index form. But what the difference between this index form and this one, they are almost same thing. But the difference is that this one has a coefficient that is above what? 1. Are we together? They start this one now. This can also be in this form. Hope you know. Yes. But because this one is 2, 1 point something, 2, 3, and above, they call it what? Standard form. But in this standard form, we have the index and the what? Coefficients. Hello? I will still describe this, but I'm just having an overview. If you understand this overview, when we start treating them one after the other, you appreciate them, okay? That's why I'm doing this. Now, under the standard form, exponential notation, or scientific notation, we have the part we call the what? Coefficient. And the part we call the what? The what? The index. Am I communicating? Yes, then that index has a part we call the power, and the part we call the base. This is the power, and this is the what? The base. The index has the power and the what? The base. Now, so a standard form, coefficient, exponential notation has coefficients and the index part of it. The index part of it has the what? The power and the what? The base. Here, the base here is what? 10. Am I communicating? Yes, now, this index form can also be moved to what? Logarithmic what? Form. These things are notations. Can also be moved to what? Logarithmic what? Form. Now, look at it now. From here, mass 111. What is the logarithmic form of 3 raised to the power 3? In the first place, what is a logarithm first? Let's even start from there. Who can define logarithm for us? What you just did day for yesterday. Oh yeah? What is logarithm? Wasn't it defined for you? No. It wasn't. Don't deny him because he will soon be here. I'll ask him. Deny him not. I will be here. He will come. I will ask him. So don't deny him. Say you don't remember. Did he define logarithm for everyone? Ewu.
Yes, I understand.
Logarithm of a number. Define logarithm of a number, sir. Oh, yeah, define it. No definition.
Let me read what he wrote.
Oh, yeah, called.
The logarithm of a number m to base b, written as logarithm nb, is the power to read the base is raised to obtain the number.
Simple.
Well, that's the definition.
Logarithm of a number. Hello. Logarithm of a number to a particular base is the power. Hello. Logarithm of a number to a particular base is the power to which the base must be raised to be equal to what? The number. Look at what I mean. This is index takes for what? 3. In logarithmic form, this is what? Log what? Log 3 to base what? 10. Simple. Have you now seen? If you put the coefficient of this, it becomes what? 2 log 3 to base 10. Does it make sense?
Yes, sir.
Putting this to in logarithmic form, you have something like this. 2 times this thing here. Times this, if 3 to the power 3 is log 3 to base 10. So it becomes what? 2 times what? Log 3 to what? Base 10. Which is simply what? 2 log what? 3 to base what? 10. Upward the same number, Naginina. Different forms. This is the what? Log what? Logarithmic form. These things are what? There are many notations, but let us not go too far. Am I communicating? Let's not do what? Go too far. Now, the same way, this number that is already as in fraction can be moved to percentage. Percentage is also a what? Is also a what? A notation too. It's also a what? A notation. So all this thing is what we mean. You now understand what we mean by what? Notation, right? Now let's take them one after the other. So let's start with fractions. Let's start with fractions. Can I clean this? Let's start with fractions. Let's start with fractions. Either you call them fractions or you call them what? Rationals. Or rational what? Numbers, okay? They're sent to rationals or fractions. Ratio. Rational came from where? Ratio, right? And when you talk of ratio, what comes to your mind is what? Fraction. Good. So either you are defining ratio or you are defining fraction. We are talking about what the same thing. What is a fraction? Okay, now let me. Under fraction, you have what? Common what? Do you know why it's called common fraction? And anytime you hear fraction, this is what comes to your mind. True of us. True of us. And anytime you hear logarithm, what comes to your mind is what? Common logarithm, right? Which is what's the common logarithm? Good. Anytime you hear logarithm, what comes to your mind is what? Common logarithm. Because that's common one we know. Base to what? 10. So anytime a number is written without any base attached to it, is in base what? 10. So the same way now, anytime you hear fraction, the first that comes to your mind is what? Common fraction. Some even tend to forget that decimals is also what? But not decimals are fraction. I hope you know. So maybe that's the reason why it doesn't come to our mind like that, because not all decimals are what? Fractions. Are rationals. Are we together? Now, here we have common fraction and we have what? Decimal what? Even from the name itself, even from the name itself, because decimals, all decimals are not fractions. That's why you have something like decimal. This decimal fraction tells you that there are some fractions that are not what? There are some decimals that are not what? Fraction. That's why it turns to what? Additive, to qualify the type of the type of, let me not go to English. Let's continue. Before I put here. Now, but the most important is that we have what? Common fraction and what? Decimal fraction. Now, you can move from common fraction to what? Decimal fraction. Are we together? Generally, a fraction is a number that can be expressed in the form of what? A over what? B. By definition, a fraction is a number that can be expressed in the form of what? A over B. Such that A over B are what? A and B are what? Integers. So that A and B can be integers. A can be equal to what? 0. But B cannot be what? Equal to what? 0. Are we together? A fraction or rational number is that can be expressed in form A over B. A and B are what? Integers. So that A and B are integers. A can be equal to 0, but B cannot be what? Equal to 0. If A is equal to 0, any denominator that divides it will give us a quotient of what? 0. True or false? But if B is equal to 0, it becomes what? Indefinite. It becomes what? Undefined. Sorry, more of undefined. Let's leave indefinite for now. It becomes what? Undefined. Undefined. In your SS2 textbook, other general mathematics, there's a topic like that there. Undefined what? Fraction. True or false? All right, now, having defined is now, we now have what? Common fraction and what? So, because the common fraction, as I talked about when I was describing log written, what always you have in your mind is what? This one. Are we together? Are we together? So, A is the what? Numerator. A is the what? Numerator. B is the what? Denominator. Then this is what? Fractional line, or whatever you call it. Fractional what? Line. Divisional line. Who said that divisional line?
I'm not the one.
What is this on your lips? Lipstick. No. Go and clean it and come in. That's wrong. Clean it and come in. That's wrong. Please. When did it? Each other nobody will disturb you, please. Okay? When other boss, you get take it, you can go. Okay, other boss. When did it? Not be so. Not be so. See me now, I can just be as safe as they go my way, no time. That time, if you don't, you look as if you don't belong. Those things are. They are good, but when did? Oh, calm down. All those things we are doing, there's a reason for that. The time you sit down doing this thing, time is going. But you will know. 1 minute is time for you here. Am I competing? 1 minute is time for you here. You will look more beautiful, Hester. I must mean 9. Teacher, you had break at my bagana. Una forget to my bagana. Now let's continue. Now, common fraction and what? Decimal what? Fraction. Now, I have described common fraction, the one we see, okay? Now, you can move from common fraction to what? Decimal. I told you before now how to determine, how to know whether a decimal number is a fraction. Remember I told you, we described that, right? How to know whether a decimal number is a what? Fraction. Not all decimal numbers are what? Fraction or rational. I told you that if it has recurring what? If the decimal digit is what? Recurring, full of us, it's definitely a what? Fraction. But if it has no pattern at all, it's not a what? Fraction, because it is irrational. It is what? Irrational. Am I concreting? That means it's not a what? A fraction. But so a number like this 0.25. Hello? 0.25 is what? Is a fraction. Is a rational what? Number. Is a rational what? Number. Now you can move decimal fraction to common fraction. And you can move from common fraction to what? Decimal fraction. So it's reversible. Is what? Reversible. Reversible. If you move from here to here it becomes what? What over what? 4. 1 over what? 4. Hello? Let's list one or two. One other. Okay, let me say 1 over 3. 1 over 8. Look at these numbers now. They are what? Common fraction. We can move them to decimal fraction by simply dividing the numerator by the what? It's simple. Hello? You want to move from common fraction to decimal fraction. Simply divide the what? Numerator by the what? Denominator. Then you get the number in what? Decimal fraction. They are the same thing. They have the same value. But they are in different what? No forms. Good. This one is in fraction, common fraction. This one is in decimals. Am I communicating? But they are what? The same what? They are of what? The same what? Value. The same what? Value. Are we together? Are we together? Now, what is 1 over 3 in decimal fraction? 0. What? What of this one? 0.125. Have you now seen the issue with continuous number? You must have to approximate. Look at it. Have you seen it here? Other ones are 0.255 and 0.125 are what? Discrete. Discrete, right? Discrete, right? But this one is what? Continuous. You must have to do what? And even if you move it back, even if you move it back to this thing, to common fraction, you must do what? You must do what? Approximate it. First, you may not get exactly this 1 over 3. You may get 1 over 3. Start giving you 144 numbers. Are we together? That's one thing with what? Continuous what number. But basically, just know that this is what? Common fraction, and this is what? Decimal what? Fraction. Now, from here you can easily move to what? Percentage. Percent. Percent. Cent is what? Cent is what? 100. Cent is what? 100. So percent talks about what? Per 100. Hello? Per 100. Per 100. So you look for it in per 100. So simply do what? To move this to percentage. Simply do what? Multiply by what? 100. Hello? Simply do what? Multiply by what? 100. You have it in what? Percentage. From here now, just multiply 0.25 to what? By 100. You have what? You have what? This is what? 25 what? Percent. Hello? Percent. This is down what? 33 point what? 33.3 what? Percent. It's okay. This one is what? 0.125 times 100 is what? 12 point what? 12.5. Are you following? 12 point what? 5 what? Percent. Hello? Then we also have, this is percent. As we have percent, there are many pairs. You can have per million, per billion. Hello? Are we together? You can have per millions, per billions. But those ones are not common. Hello? Simply do what? Multiply by 1 million, okay? You get it there. Maybe after the unit will not become. Multiply this to 0.25 by 1 million. Is P 2 what? 250,000. 250,000 per what? Billion. But it's not common. But we meet it when we talk about concentration. When we go to parts per billion. I just mentioned this. When we go to concentration, parts per billion. You know, that's when I will throw more light on that. But just know that such exists, okay? The one that is common to us now is this. Are you aware that with this I'm done with this topic?
Yes,
Are you aware? We are done. Other things is just to start doing just operations in this notation. Simple. Operations. When we talk about operation now. Hello. What I'm going there to start doing is this operations in these words notations. When I say operations, I mean the basic mathematical words operation like addition, subtraction, multiplication, and what? Simple. Once I carry out these operations, we are done. What if you can add in standard form, subtract, and they divide and multiply? If you can add fractions. This is a three topics. It's not true. You can add fractions, multiply fractions, divide fractions. You are good to what? Go. Now, so if we pick up we are in fractions, right? Yes, sir. Now let's talk about operations in what? Fractions. Hello? Operations in what? Fraction. Operations in fraction. Operations in what? Fractions. Now, before we do that, there's something I want to explain. Have you heard of the term equivalent fraction? Yes. What are equivalent fractions? What are equivalent fractions? Have you heard it? Yeah. Oh, yeah. What are equivalent fractions? You know what? She said that equivalent fraction is the arrangement of fraction in another. Now listen. Equivalent fractions are fractions that are equal in value, irrespective of the magnitude of their denominators, numerators, and their what? Denominators. Equivalent fractions are fractions that are equal in value, irrespective of the magnitude of their numerators and what? Denominators. Equivalent fractions are fractions that are equal in value, irrespective of the magnitude of their numerators and what? Denominators. See what I mean? Look at this 1, 2, 3, 2 this four common fractions on the board. Look at them. First one is 2/4. Second one is what? 1/2. Third one is what? 3/6. The last one is what? 2,000 over what? 4,000. Irrespective of the magnitude, this one is 2,000. This one is just what? 1. This is 4,000. One big number. This one is what? 2. They have the same what? Value. 4 of them are what? Equivalent. So let's check their value. 2/4 is what? 1/2. 1/2 is simple what? This is what? 2,000 over 4,000 is what? Don't they have the same value? And even if you like, you can push them to what? Decimal. They what? 0.5, 0.5, 0.5. But if you look at them, you become confused. Hey, how do I even solve this fraction? They have the same what? Value. Irrespective of the magnitude of their what? Is it clear? Yes. So these are what? Equivalent what? Fractions. Now, and if you are given a particular fraction and you want to determine its equivalent, if you are given a particular fraction and you want to determine its equivalent, simply multiply the numerator and the denominator by the same number. If you are given a particular fraction and you want to determine its equivalent, simply multiply the numerator and the denominator by the same what? Number. You get equivalent number of equivalent fraction of that what? Fraction. Am I computing? See what I mean? See what I mean? You have 1/2 becoming down to. What is the simplest form here? Simplest here is what? Now let's start from 1/2. If you want to get equivalent of this 1/2, now what do? You can get it by multiplying the numerator and the denominator by what? By what? The same number. If you multiply the numerator by and the denominator by 2 now, you have what? 1 times 2 is what? 2 times 2 is what? Are we together?
No.
Are they equivalent?
Yes.
So how did you get this to 2/4? Dividing.
Okay, multiply by
Is that not what I've been saying here since? Why are you laughing, Victoria? Is that why I'm laughing? No, I said, I think the problem is that both of you are busy copying without even reasoning what they're copying. I said, equivalent fraction, equivalent fraction. Okay, what was the first thing I said?
Determine the equivalent of the fraction multiply with.
Good. If you want to determine the equivalent of a particular fraction, first step is to do what? You can multiply the numerator and the denominator by the same what? Number. You can choose any number you want. I chose 2. I multiply this and this by 2. It gave me what? 2 over what? 4. But you cannot. Okay, it's okay. You can. It must not be only multiplication. No, it can also be what? Division. Hello. Am I complicating? You can divide the numerator and the denominator by the same number and still get equivalent to what? Fraction. Now look at it this place now. 1/2. If you multiply here by 2 to give you what?
2.
You multiply the denominator again by the same what? 2. It will give you what?
4.
Now let's look at division. If you divide here by the numerator by 2, it will give you what?
1.
If you divide the denominator by the same 2, it will give you what?
2.
Does it make sense?
Yes.
Now look at this thing now. You may choose to multiply by 1,000 or 2,000. You can say, okay, if you multiply here by 1,000, it will give you what? 1,000, right? Multiply the denominator by 1,000, it will give you what? 2,000. It's not equivalent to 1/2. You can choose to do it to 2,000 with any number. The most important thing, the basic rule is this. Whatever you do, the basic rule is this. The basic rule in generating equivalent fraction of a fraction is that whatever you do to the numerator, do the same thing to the what? So if you're multiplying, basically two things you will do to get an equivalent fraction is what? Division and what? Multiplication. So it's either you multiply or you divide, but you must use the same what? Number. Hello? So you must use the same number to multiply the numerator. You don't go and multiply the numerator by 3 and go and multiply the numerator by 4 and tell him that you get the equivalent fraction. Okay, I see. It can happen. So it must be by the same what? Number. If you do it that way, you can now develop what? Another equivalent fraction. So with this now, I will stop here. By the time we go into ratio and proportion, I will not tell you the importance of this equivalent fraction. This your cross multiplication you have been using in your primary school. It came from where? Equivalent what? Fraction. But you will not appreciate it now because we have not treated proportion. By the time we go to ratio, proportion, and variation, specifically proportion, I will remind you of what I said today about what? Equivalent what? Fraction. Let's finish the topic we are doing now. Okay? These things, remember I told you that these things, they are connected. Hello? They are what? Connected. If you don't understand this place, the next topic will become trouble for you to understand. Hello? That is how it goes. So please, I keep begging you, I keep saying this 1,001 times. Please, try as much as possible to grab whatever we are doing as it is hot. Don't wait till your exam, you start writing, you start reading, you won't understand anything. So I don't want that to be our portion. Now, this is what we call what? Equivalent what? Fraction. Now, having understood that, let's go to what? Where's your time? Having explained that, let us go to what? Operations in what? Fraction. We start from where? Okay, buddy. Where is it? Okay, your pocket is the. Okay. Now, let's go. Let's continue. So we look at what? Operations and fractions. Good. Are we together? Are we really together? So now let's look at addition. Hello?
Yes, sir.
Let's look at addition. Fraction. 1/6 plus 3/4 plus. This is your primary one. This thing now we are doing it in this higher institution. It's not funny. I'm not supposed to be doing this, but I know why I'm doing that. I know I'm doing that. So that all the holes, all the valleys will be what? Filled up. A lot of people have valleys that they jumped and came here. So if you know that you jumped a valley, they put a bridge for you to cross that valley. Instead of filling it to have a level ground, this is time to do what? Fill it. All right, now look at this. What is the first thing we should do when you have what is LCM? Explain what lower common fraction is. Is it not lower common what? Fraction.
No,
What it is, explain it. I want someone that will explain it to me. What is this? Fine, let's see here. Like, what is it? What is the meaning? Tell us. Who knows it here? Come and explain. Come. Come now. Come. In the motor, you explain like one professor. Come now. Are you afraid? No, I know they train naive people. Come out. Go to the board and teach us. Go to the board, Professor Muke. Where's your spec? Or you wear your spec and go to the board. We are professorial Google or Google. Google. Oh, yeah, fast. So what is lowest common multiple? What does it actually mean? Okay, what is lowest common multiple? What does it mean? That's the question. First of all, what is a multiple? You will start from there. What is a multiple of a number? Let's start from there. Hello? Who can define multiple of a number for us here? Multiple of a number. Let me give you a clue. Multiple of a number is opposite of what? Factors. Hope you know. Are you aware? Multiple of a number is opposite of the factors of what? So now, with this clue now, who can tell us now what is a multiple? If you hear multiple of a number, what comes to your mind? Oh yeah. Okay, let's start from factors. What are factors of a number? What are factors of a number? Here maybe wo. Here maybe wo. Here or maybe wo. What are factors of a number? Hello. Someone is speaking.
Factors of a number is like number you multiply to get a particular number.
Okay, she said that factors of a number. She said that hello. She said that factors of a number are numbers you multiply to get that what number. Is it true? Example. Hello, shh. Example. Shh, please. Hello, see. On a more serious note, do you have even a jaleze?
Exact factors.
Genti. Which could na mommy, daddy, what is? So these things are what you should know. It's not a joking matter. Let's just listen.
Factors of 12, we have 3 and 4, we have 2 and 6. Then factors of 25, we have 5 and 5, and 1 and 25.
Good. She said that factors of a number and numbers you can multiply to get what that number. So she said that factors of 12. Are 1 and 2 are factors of 12? Yes. Yes. So 2 and 6 are they factors of 12? Yes. 1 and 3. Oh yeah,
Okay, 1 and 12.
If go to there 6, if go to there 12 now, then you start listing the factors. Oh yeah, there 1 and oh yeah, 1 and 12. Fast. What else? 2 and 6, right? Yes. There 2 and 6. Not there. Come. 2. 4 and 3. Anyone? 3 and 4. What else? Anyone? Now, hello. No, cover it. Now look at these numbers now. If these are factors of 12, this build up what 12. Now, what can be multiple of 1, 2, 4, 3?
12.
Come again.
Can 12 be a multiple of 12 too?
Yes.
Can 12 be a multiple of 6? Is it possible? Yes. Is it possible? Yes. So can you list multiple of 12 now? Can you list multiples of 12? I said list. No, not there. Just start from, just list them here. Come here now. Come here. Can you list multiples of 6 here? Lead them like this. Just like listienka. Dionisi. List here. Just calm down. Just leave this. Is it true?
Yes.
Is it true?
Yes.
Shift. Is it true? What else? Continue. Now listen. Now listen. Can all this number divide 6 without remainder?
Yes.
Listen carefully. Can all this number divide 4 without remainder?
Yes.
Can all this number divide 2 without remainder?
Yes.
12 is a multiple of any of these numbers. Are you together?
Yes, sir.
The same thing with you. So what is the lowest common multiple? Then Oya, solve this fraction for us. Do you now understand what a multiple is?
Yeah. Yes.
Please, continue. What else? Help her now. People are laughing at her.
Okay.
So what's the common?
You know multiply 2 times 3.
Is what? Is what?
4 times 3.
Is
That's
12.
12. 6 divided 12. 2 times 1. 4 divided 12.
3.
Times 3.
9.
12 divided 12. 1 times 2. 9 plus 2. 11 plus 2.
Stop. Do you understand what she did here? I asked a question here. I asked a question here now. I said now, what is now the lowest common multiple of 6, 4, and 12? From here, Keta. Listen carefully. Let's dissect this term. LCM. Lowest common multiple. Now look at these numbers now. All of them. Are you aware that they have, these 6 can have a multiple that is above 12? Are you aware?
Yes.
Are you aware? Yes. Good. It's not 2. 4 can have a multiple that is above what? 12. True of us? 4 can divide 8. Is not? 12 can also have a multiple above itself. True of us? Now, but the one that is common among 1, 2, 3, the lowest you can attain that can be common among 3 of them is what? 12. Is what? 12. The lowest that can be common among 6, 4, and 12 is what? 12. Does it make sense to you? The lowest that can be common for 3 of them. Yes, this one has. Can 12 have a multiple below it? Can it? Can 12 have a multiple below it? Can 6 be a multiple of 12?
Yes.
Huh? Can 6 be a multiple of 12?
No, sir, confused.
6 can only be a factor of 12. It cannot be a multiple of 12. You can't be saying that 6 is a multiple of 12. 12 equals 6. What is a multiple? Huh? Good. Now, can 12 divide 6? Can 12 divide 6?
Yes.
And get the whole number?
No, sir.
No, I'm saying now, what's the multiple?
The number that can divide the whole number without remaining.
This thing now, 6 is a multiple of what? 6 is a multiple of what? 6 is a multiple of what? 1, right? 2, right? 3. Can 3 be a multiple of 6? No, that's the point I'm making. That is the point I'm making. 4 cannot be a multiple of 12. True of us? But 12 can be a multiple of 4. And 12 can be a multiple of what? 6. And 12 can be a multiple of its own, which is 12. So the lowest multiple that can is common among 12, 4, and 6 is what? 12. It can be 4. Understand the term lowest common, BH common. In what? Common. So the common that is actually that 3 of them can be factor 4 is what? 12. You can never 12 cannot be a multiple of what? 12 cannot be a multiple of what? 4. It can be a multiple of what? 6. But 12 can be a multiple of its own, which is what? 12. Then 4. Then 12 can be a multiple of what? 4. 12 can be a multiple of what? 6. And 12 can be a multiple of its own, which is 12. So the lowest multiple that is common to 3 of them is what? 12. That's what you will do for your since you're not in school. Without knowing what you're doing. That's what I will expose a lot of things you'll be doing since without even knowing what they're doing in this course. See it here. That's what he did here. You don't even need to do all these things. With here, I can simply tell you what is. That all this belongs to you. You don't need it. From here, I'll tell you, simple. Does it make sense? So you now do you divide. Continue. C divided by 6 divided 2 is what? 2 times 1. I agree. 4 divided 3 times. I agree. Okay, continue.
13 over 12. 1 over 1.
Now, I want to make another point here. Please, if you are working with. Okay, I think okay. No, after this, I'll list types of common fraction. Okay, I'll list it. Now, look at this number now. Please, if you are solving fraction for me, and after solving, you leave the answer like this, you have failed that question. This thing is unstable, okay? Move it to what? Mix what? Fraction. This is improper fraction. Move it to what? Mixed fraction, okay? Please note it now because some people say made that mistake. If you get that 13 over 12 and stop there, sorry, that question is gone. You failed it. So, you must bring it down to the lowest what? 10. Hello? If you get 2 over 12, bring it down to what? 1. Don't leave it at 12 over 12 for me. It depends on the question. If you are asked to leave your answer in common fraction, leave it in as what? Common fraction. Don't move to what? Decimal. Follow the instruction you are given, okay? Follow the instruction you are given. Now, That reminds me, I before going into the operation, I would have, but it's simple. It doesn't. We have what? Proper what? Fraction. We have what? Improper what? Then what? Mixed what? Mixed what? Fraction. This is one of a review of mass review of what you have been doing since, to throw more light on what you don't understand. Those things that they were telling you in your preparatory school. Proper, improper, and what? Mixed fraction. Improper fraction, the numerator is less than the what? Do you agree with me? Yes. Good. In the improper fraction, the numerator is greater than the what? Numerator. So when after solving calculation and you get the answer appear as improper fraction, please move it to what? This fraction. Because the numerator should always be what? Less than the what? That's why it's a fraction. If we get fraction, be referred to part of a whole. True of us, part of a what? That's fraction. It's not true. Part of a what? A whole. If you divide some, if you have a range now, part of this whole is what? Fraction. So if you have 1.5, that means we have a whole. True of us, which is what? 1 plus what? Half. Sorry, not half. This is part of this whole. The shaded part is what? Half, which is what? 1 over what? 2 of this whole. So the answer is what? 1 over what? Not what? Not what? 13 over what? So not what? 3 over what? 2. This is wrong. Don't leave that. Don't leave the answer like this. Have you seen why I'm so serious about it? It should be part of a whole. So the only thing that can exist is a whole and part of a whole. You don't make 30 is part. How can 13 be part of 12? Does it make sense to you? It doesn't make sense. 13 cannot be part of what? 12. So you must bring it down to the lowest what? Term. So you move it to what? Mixed what? Fraction. Okay? That's what I wanted.
If the answer is a proper fraction,
no need now. That's why it's part of a whole. The numerator must always be what? Less than the what? Denominator. That's why it has improper. Move it to mix a whole number and a proper what? Fraction. Combined together. Does it make sense? Does it make sense?
yes, sir.
Good. Now, after this now, who do not understand this thing, don't hide. Do not hide. Okay?
They tend to use this 6 multiple of 12 and 12 multiple of 8.
Okay. Now let me explain better. Remember, before explaining this estimate, I told you that multiple is opposite of what? Factors. Now, factors are numbers you multiply to get another what? Number. So, now, we listed factors of 12 here. 1 and 2 are factors of what? 12. True of us. 2 and 6 are factors of what? 12. Because if we multiply 1 and 2, you get what? 12. If you multiply 2 by 6, you get what? 12. If you multiply 4 by 3, you get what? 12. These numbers here are factors of 12. This direction is what? Is what? These numbers are factors of 12. Okay? But 12 is a multiple of these numbers here. Multiple. 12 is a multiple of these numbers. Of. This is what? Multiple of. What it means is that these numbers here can divide 12. Without what? Perfectly. Now, we now listed about 3 numbers. You want to find the lowest common multiple. Common. 3 of them have what? They are different multiples. What is the multiple that is common for both of them, for 3 of them? And okay, now look now. Can we list multiple that is common to 6, 4, and 12? Is there any multiple common to 6, 4, and 12? Is there any multiple common to 6, 4, and 12? Is it the only multiple? Okay, now let's list their multiples so that I can appreciate this better. After this one, I don't think, come in, you have any issue on this again. Hope you're following.
Yes, sir.
Let's list the multiples of 6, 4, and what? 12. Let's go. 6, 4. What are multiples of 6? 1. So you are listing the factors of 6. 6 from 6. 6, 12, 18, 24, 30, Let's stop here. Multiples of 4 is what? 2, 20, Let's stop here. Multiples of 12 are what?
24. 36. 52.
Let's stop here. Watch. Let's trace the multiples they have in common.
52.
60. Good. Now let's look for the multiples they have in common. Let's trace here. Do you have 6 here? No 6 here. So 6 is not common to 3 of them. There's 12 here. Do you have 12 here?
Yes.
Do you have 12 here?
Yes.
So 12 is common. 24. Do you have 24 here?
Yes.
Do you have it here?
Yes.
Do you have it here?
Yes.
If you keep going down, they are becoming bigger. So they have 12 and 24 in common. What is the lowest?
12.
It's 12. So 12 is lowest what? Common multiple between among what? 6, 4, and what? 12. Does it make sense now? Good. So that's what people have been doing here in your primary school. Ask.
So you take here that 1, 3, 2, and 6 is a multiple of 6. Like, and you say, okay.
Cheta where is I asking now 1, 2, 3 are multiple of 2, 6. The one game. Please, before you to know exactly what I say, please listen to my lectures. Please don't hear and that and that and that. So now, is it clear now?
Yes, sir.
Good. So why I said I explain this? There's a question I asked before. I now say which one is we say 2. That's why I took it became clear to me that I need a lot of explanation here. Okay? That's why I do what? Now, if you say 2, let's look at it now. What is actually 2? 2 is a common factor, even though it's not highest. We have HCF, right?
Yes.
We can find HCF of this highest common what? Fraction. 3 of us, good. You take all their common factors, not fractions, sorry, common factors. Then take the one that is what? Highest they have in common. That is the highest common one factor. So let's continue, please. Now, is it clear now? So, does anyone have issues with this addition? So if I give you a question to solve addition of fraction form, you can solve it.
Yes, sir.
Okay, ask a question.
This number is does it mean that
Good. No, sorry. They are factors of 6. If you want to say common factor, if you say common, you are comparing 3 of them. But the one under 6 are factors of 6. Why 6? Listen carefully. The one under 6 are factors of 6. Why 6 is a multiple of each of them? They are not a multiple factor. Is that a multiple of what? Factors. I said that 6. These numbers under 6 are factors of 6. 1 is a factor of 6. 2 is a factor of 6. But basically, factors are better taken in pairs. 2 of us. even though you can have 2 times 2 times 3. But just know that if you say that 2 is a factor of 6, it sounds somehow, even though it is, but can 2 multiply 20? Can it give you 6? That's why I said that it's somehow incomplete. To just single out a number, say that it's a factor. You have to bring up another number, pair it, either double or other 1 or 2 numbers before you can say you are defining what factor. I'm not committed. So if you say 1, that means 2 can times any number to give you 6. That's what I say in 3 of us. I'm not communicating. Now that's why if you see here, I did them in pairs. I did them in what? Pairs. Now, so does anybody have issues with addition of fraction? Now. So if I give you like pace and full put about the addition na fraction, now let's go to what? Do we solve one more?
Yes.
Yes, sir.
Okay. I clean board, prof.
Yes.
So what is the first thing you are doing? You should do here now. Try that one. Do it. Let's see.
8 times 1, 8.
Hello, Tom. Speak to the class. No, you are blocking the. Say like this. The teacher should say like this. Talk to your students. Eleven over what?
8.
Okay, continue. Yes. Add now. Yeah, find LCM, yes. Hey, why was here? Just simply say, first of all, okay, which number can 8 divide and 5 divide at the same time? 40. Is there a number below 40 that they can divide like that? So write 40 is there's no time. You don't understand what we did now? Eh? Good. I continue.
5 plus 11. 5 divides 40. Plus 9. Plus 9. 17.
Number 72. What is divided by
You know here? 8 as what? Plus.
8 times 9.
Okay, times okay. You added. Okay.
5 divides 40.
8 times 9.
72. 55 plus 72.
127.
127.
3 on yourself.
Number what?
7/40.
Do you agree with her?
Yes.
Huh? Do you agree with her?
Yes, sir.
Okay. Let's go to practical questions. You can clean the board. Put this in down. I'm detecting now. Okay, some people are still writing. Some people are still writing. Just allow them to finish. Yeah, okay, now let's go to the practical question now. All right. A pharmacy technician uses 1/4 flow downs. Put FLOZ. That's the unit flow downs. We still do it in FL. Okay. You are okay. Just I'm trying to detect the units. This is the unit flow downs. Now, a pharmacy technician uses 1/4 flow downs, comma, 2/3 flow downs, comma, and 3/8 flow downs of a solution. Of solutions to prepare an IV admixture. Admixture. Then mixture.
Okay.
Admixture. Then mixture. Full stop. How much total solution does she use? How much total solution does she use? How much total solution does she use? What's the answer? Solve for us. Please, I want to point out something here again. I don't play with denominate numbers. You were solve, you keep solving. They never solving. There's no unit in your answer. No unit in your answer. You have fed that question. Please, don't play with what? Unit. As you're writing my exam, see yourself as if you're actually working. Don't just write it as if you are writing mathematics examination. Write as if you are actually doing what? Working. Let's assume you are working in place you are doing manufacturing. Then you weigh. You just write 290, no units. You've caused confusion in the whole company. Is it 240 ml that you are talking about? What did you measure? Am I communicating? It's a serious issue. It's a serious what? Issue. So don't make mistake there, please. You have started shifting your unit. You not put unit. You are. Do you think you are solving abstract mathematics? The unit should fit the unit that place you are working. So you don't forget it at the end. Yes. So you don't forget what you are doing. What are you doing? Let me help you. It's what? 1/4 what? What? Plus what? Through what? Downs. Plus what?
3/8.
3/8 what?
Down.
Because all of them have the same unit, you can shift it right and say what? Is equal to what? 1/4 plus what? Plus what? 3/8. All in what? This one is acceptable. So you don't forget. So you don't forget your unit at the end. That's the idea. You now solve this thing inside a bracket. Then open the bracket. It will have the unit. The answer is what? 1 over 7 over what? 24 flow downs. Good. This an example of a practical what? Don't mind the units, okay? Try to remember the rules of fraction. Okay, don't allow the unit to confuse you. Look at what you are. See the fraction in it first, then solve, but maintain your what? Unit. There are people that when they see this type of thing, there are people that don't like solving word problem. When they see it, they will throw off balance. True of us. So please, these are the practical questions you'll be seeing. The abstract mathematics we did here is just to help you understand the denominator numbers that we'll be making use of. Am I communicating? So with this now, you can no matter how anyway we'll see some more questions. Your statistics lecturer is here. I will stop for now. In our next class we'll continue from here. Okay, we'll solve one or two questions there before we move to the word subtraction of fractions. Any question? All right, thank you very much for today. Thank you, my assistant lecturer, for today. All right, we'll see tomorrow. Yes, tomorrow. What is it? Huh? What's that? Yes. But I will try. I'll see. Hello. I'll try and come around. It's 7:45 now. I'll try. I'll try and come around. All right. See you.